On the second part of this lecture, we're covering how to solve logarithm equation. Again, this is solving logarithm equation is also the part of section 6.5. So the first Roman we already learned how to solve exponential equation. So let's continue with solving logarithm equation. So solving log equation, and there are several methods of solving log equation. One of them is we have to use log principle. Log principle is the principle I already mentioned on when first time I introduced log function. Log base b of x equal y, then x equal b to the y. So that is the log principle, and we can use that to solve log equation. For example, of course, not all the log equation can be used with log principle. So log principle sometimes it doesn't work for some type of log equation, but most of the time it works. Most of the time they use right at the beginning, or they use at the end when you simplify the log equation, a very complicated log equation, you simplify it down to a simpler one, then you might use log principle. So I already said many times, solving equation is very flexible. You have to be flexible. You have to be adaptable. You have to see which one, what principle, what method is the best for each type, for each log equation, for each equation. Okay, example. What if I have something like this? Log base 10 of 3x plus 5 equal to. Okay, this is a very easy, simple log equation. It's a very standard one. The argument over here is 3x plus 5. So when you solve log equation, you have to see which one. You have to point out which one is the argument. The argument is very important. If you don't know which one is what part of the equation is the argument, then it's very hard for you to be able to use log principle or any different approach. Okay, so you must know which part in the equation is the argument. So in this equation, the argument is 3x plus 5. The base is 10. So if you apply log principle, so you're gonna have 3x plus 5 equal 10 to the second power. So you kick them up. So this 10 will be invisible 10 right here. You kick them up. So 10 raised to the second power. So which is give you 3x plus 5 equal 100. Then it give you 3x plus 5. This equal 3x plus equal 95. And now you have 95 divided by 3. Okay, so that is the solution for this equation. You can use log principle twice. For example, in this case, what if I have log base 2 of log base 2 of x equal 4? So the first step, again, we need to figure out what part is the argument. So you see, in this case, the argument is everything inside the parenthesis. So the argument is the log itself. Okay, so this is the argument, this is the base. So if we apply log principle, so we're gonna have log base 2 of x, which is the argument, equal 2 to the 4th power. You kick this one up. Okay, so 2 to the 4th power is 16. So we have what? We have log. So I think I'm gonna divide the paper into half. So easy. We gotta save paper. I'm sorry. There you go. Let's split it. So we have log base 2 of x equal 16. Now I'm going to apply log principle as another time, second time, so it becomes x equal 2 to the 16. Right, 2 to the 16 is a kind of big number, so you go ahead and plug it in calculator, then you get the answer. So you see that in this case I apply log principle twice. Okay. Second method we can use to solve log equation. This is the equivalent property, which equivalence property can be used when you solve exponential equation, but in for log equation it's kind of a little bit different, just a little bit. Okay. So equivalence property said that if we have log base a of x equal to log base a of y, then this imply x equal y. So this is equivalent property. Okay. So you see the property is that if you have two log with the same base, the log must have the same base. If it have different base, then we cannot set the argument equal. So the argument over here is x, the argument over here is y. So we cannot set the argument equal each other. Okay. Whatever over here a and over here b, then we cannot have it. So must have the same base. Okay. And how we're going to use the property to solve? For example, this is very standard one. You already learned in college algebra. Plus log base 5 x plus 1 equal log base 5 of 20. Okay. So you see over here, the argument is x, the argument is x plus 1, the argument over here is 20. So if you have two log add together, so we just give you the log of the product. So we already know this with the formula or the property or the log formula I already introduced in the previous video, equal log base 5 of 20. And now what you see that the base is the same, right? Base 5 and base 5. Because the base is the same, then I can set the argument equal to each other. The argument in this case will be everything inside a bracket, so we become x plus 1 equal 20. Okay, x plus 1 equal 20. Then this becomes x squared minus x plus x minus 20 equals 0. This is quadratic equation, everybody know how to do it, so I factor them, so it becomes x plus 5x minus 4 equals 0. Right, then equal x plus 5 equal to 0 using the zero product property. So equal negative 5, x equal to 4. Of course you have to check, right? X equal to negative 5, you plug them in, doesn't work, so this is extraneous. Okay, I mean it doesn't work. That is not a solution. So the only answer we have will be x equal 4. Okay, so that is the way you use equivalence property. I mean, most of the equation, I mean, in college algebra, when you solve log equation in college algebra, you see, you can apply the equivalence property right away at the beginning, but in pre-calculus, you have to do a couple more steps, right? And I can give you something like this. Let me see. Another example of using equivalence property. Let's see, I can find something or not. All right. How about this? Something very interesting. Very interesting. Okay. Example 1, example 2, example 2 of equivalence property. Okay. What if I have like this? I have a log base 2 of x minus square root of x squared minus 1 plus log base 2. You see that all the base is the same. Oh, let me see, this is log base 2 or log base 3. I can't see it. Textbook is so small, it's blurry, so no, this equation as well. This equation using the principle, and we're gonna go through this later. Okay, we're gonna go through this later. And when after I introduce all the method. So this is for the third method. I'm sorry. So let me do something with so that we can use the equivalence properties, something like this. I'm sorry. What if I have 3 over 2 log base 4 of x plus 2 square plus 3 equal log base 4 of 4 minus x to the third power plus log base 4 of x plus 6 raised to the third power. Okay, so you see it over here. This is very interesting problem. So we have 3 log. We have 3 log with the same base, and you see that with the same base you can add or subtract, right? You can combine them as the product. So you see that in this one you can drop the exponent down, so become you drop it down, so become 3 log x plus 2 only, because you drop it down you cancel number 2, and this is you drop it down, so become 3 log base 4 4 minus x plus 3 log base 4 x plus 6. Right. Then on the left hand side I'm gonna just skip for the time being. 3 plus 3, right? 3 plus 3 give you 6 log base 4. Oh, you cannot do it. You cannot add it like that. You just can factor them out. So factor number 3 out. So you have log base 4 minus x plus log base 4 6 plus x plus 6. And the same thing over here, I factor number 3 out, so I have log base 4 x plus 2 plus 1 equal to 3. So you add 2 log at the same base, so they become the product. So it become log base 4 of 4 minus x times x plus 6. Okay, so it become a product. Okay, and what we have here, we see that we have oh, this one probably this is not using equivalence property either, because we can cancel number 3 here. Then we have log base 4 x plus 2 plus 1 equal log base 4 minus x plus 6. Let me see I have any careless mistake or not. I probably wrote down the wrong one. It's 3 over 2, so you drop it down. So you drop it down, so it become 1 over 2. So you drop it down, so become 3. Okay. So 1 over 3. Let me see, I drop it down. So we drop it down. So we drop it down, so it will be 3, 3. You add them up, you factor number 3 out, so you have log of the sum. See if you log of the product. But we getting stuck with number 1 right here, because when you factor, it's kind of weird though. Probably I mess up something. So 3 over here. Okay. Alright. So over here, log base 4, x plus 1 plus x plus 2 plus 1 equal to log base 4 minus x plus 6. So in order to apply equivalence property, you can do like this. Log base 4 x plus 2. 1 is log base 4, right? So equal to log base 4 minus x plus 6. So you see that 2 log add them up with the same base, so they become the product. So it become log base 4 times x plus 2 equal log base 4 of 4 minus x plus 6. Right? Very easy, right? See that? This is a trick right here. So 1 you can change to log base 4, because if you leave 1 over here, you cannot do. Actually, you can, but you in that case you have to use log principle. You not use equivalence property anymore, because I try to show you equivalence property. So I change it. So right now the same base, so I can set the argument equal each other. There you go. Okay, so that's the trick right there. Okay, now it become very simple equation. So 4x plus 8 equal to 4x plus 24 minus x squared minus 6x. So 4x cancel out, so you're gonna have x squared plus 6x minus 16. Okay, equals 0. Now you can factor x plus 8, x minus 2 equals 0. Then x equal negative 8, x equal to 2. Okay. And both of them seem to work, because I mean, I'm not going to check it, but it's your job to check it. But I think that the negative 8 plug it over here, negative 8 plus 2 give you negative 6, negative squared 36. So I think both of them work. Okay. Of course you got to go back and check, but I think both of them work. Don't forget it. Don't forget checking every time. Okay. Well, you can you can do like this. X must be greater than negative. No, probably negative 8 doesn't work. You plug it in, negative 8. Yeah, it doesn't work, because negative 8 over here plus a negative, so you have negative to the third power is negative. So you don't have log base 4 of negative number. So this is not work, because this is extraneous. Okay, so only this is the solution. Alright, so that is the way you use the equivalence property. I mean, in this problem, actually, you can use the log principle to solve for this equation. But I mean, because we do an equivalence property now, so I'm trying to do the trick there so that you can apply equivalence property. All right. Good. So that is the second method of solving log equation. The last method, of course, is the naming variable. So you see the naming variable is the method is it can be applied to any equation. I mean, a naming variable is I shouldn't say the method. It's a process. It's one of the steps, because after you name a variable, you probably have to use block principle or equivalence property to solve for the equation. But let's consider it as like the method anyway. So you know that naming a variable can be used anywhere. Okay. So on the third part, on the third, I'm going to use another piece of paper. Let me see. Oh, sorry. Okay. So the third approach be naming variable. Okay. Name variable can work for any equation, not just log, not just exponential. It could be radical equation, absolute equation. This is a process. Okay, it's a process to make it simpler. All right, so let's start with this problem. I mean, this problem I saw in another pre-calculus text. It's the standard used by our school before, but probably right now they don't use it anymore. But it's I mean, it's a standard textbook. Okay, it's not advanced or anything. You probably see this problem in the text we currently using, but probably, I mean, because every time they republish the text, I mean, they just put the old problem back into the new text in a way. They just add more problem, but the old problem is still there. All right, so let's do this one. This is very interesting one. It looked kind of hard at the beginning, but I mean, it's not really that bad at all. So what happened? X minus 1, everything raised to log base 10 of x minus 1 equal to 100 times x minus 1. I mean, you in this course, this level already. It means what? It means that you're not gonna do math by routine. You have to do math by logic. That's why I want you to be flexible. I want you to be more adaptive. Adaptation is very important. You learn the concept, you learn the logic, and you can apply anywhere. Okay. So because we want to name variable, and you see that we had a pattern x minus 1 on the left hand side and x on the right hand side. So in order to make it simpler, I name let u equal x minus 1. If you let u equal to x minus 1, then our equation become what? Our equation will become u log u equal 100 u, right? Right? I think let's just go ahead and put this away because we probably don't need it. Okay. So what next? You see on the left hand side is u, on the right hand side is u. In order to make it simpler, so I divide both sides by u, so I have u log u over u equal 100. Alright? And you log u of u is u to the first power, so u log u raised to the log u over u, so it become u raised to log u minus 1, right? Equal 100. And 100 is 10 squared. Remember the formula, x to the n over x to the m is x to the n minus m, right there. X to the n over x to the n over here is 1, so it will become x to the n minus n. Okay, I apply right there. So now what? Over here is u, and over here log base 10, right? And over here is 10. Just think about it. If I take log base 10 both sides, so it become log base 10 of u raised to log u minus 1 equal square. And log base 10 of 10 squared is nothing but 2, right? Because log base 10 of 10 is 1, so we have 2 left. Okay, the formula we already learned. Alright, so this one we apply one of the formula again. So this is exponent inside the argument, so I can drop it into the front, so become log u minus 1, okay, time log u equal to. Alright. And now I distribute it, so become log u square I mean log u times log u is log u square, log square u, not log u square. Log u square is different. So log u totally square or log square u. So you can write over here is as this, because this is the same meaning as this. Okay, so log square u minus log u minus 2 equals 0 on the left hand side. Okay, now you see it's in quadratic form. I left t equal log u, then my equation becomes t squared minus t minus 2 equals 0. I factor them out, so it becomes t minus 2, t plus 1 equals 0. So 1, t equal to 1, you plug it, it doesn't work, right? Because there's no way you take log of something and equal to negative. You remember the graph, it's always positive. So this is not included, it's extraneous, so all you have is t equal 2. So you have log u equal 2, right? Then u equal 10 squared would be 100. So u equal 100. You plug them back over here. So 100 equal x minus 1. Plug them back into the original because we want to solve for x, right? Then x equal 99. Oh, 101. X equal 101. I'm sorry, 101. There you go. There you go. Okay, it's a very interesting problem. You see that in this problem we have to name variable twice. Okay, but you see that I mean I just learned the concept. I use the logic. I mean, because every problem, every equation is different. You know, you cannot solve equation by routine. You have to be flexible, adaptable. Okay. Alright, so the solution is 101. Alright, so that is the first example in naming variable method. I can give you another one. I think that the one with radical last time, and I said we shouldn't do it because it's, we can use the naming variable method. Okay. Let me see. Or maybe we can pick another one, because every time we want to deal with radical, then we have to solve radical equation, which is good. I mean, you guys already learned solving radical, but let me see. I can give you something else, something a little bit similar before we can do the radical log. Okay. Interesting. Yeah. Okay. Let me see how we're gonna do this. Okay. Example 2. Let's try pick another one, you know. I just want to let you know that every time we do math together, I mean, especially when we solve equation, I want you and me work together. So that's why I never have the solution of that, because sometimes I ask the student to figure out their own way, and I try to adapt myself to your way. The same thing, you adapt yourself to my way. Okay, so I'm trying to adapt myself to your own method, which is better, because I think that the way the way you learn, the way you think, of course, different from my way. So if I adapt myself to your way, it will help you more. Okay. Let me see. Solving log or exponent is hard. It's not easy. I mean, believe me, it's not simple at all. It's not simple at all. But I mean, it doesn't mean that we cannot do it. You know. Okay. Let's see we can do this. Okay, let's do with the problem with radical, because it looks like that there's only one with I have with the named variable right now. So what do we do with this? Log base 2 of x minus square root x squared minus 1 plus this is not easy problem, okay, but it's not really that bad. Square minus 1 equal log base 6 x plus x squared minus 1. Okay, so what we see over here, we see that the base is different. If the base is different, we can apply the equivalence property right away, right? We see another thing. We see that is everything inside parentheses is kind of the only one that difference from each other is the minus and the plus. It's the sign. This and this is the same, which is good, but the base is different. Okay, so what we're gonna do here? I don't know if you can see the relationship between x minus square root of x squared minus 1 and x plus square root of x squared minus 1. They kind of relate. They had related to each other. Actually, that's the different of square right there. They're different of square right there. If you set and they not even they in different of square, and they are conjugate of each other. They're conjugate of each other. So if I let t equal x plus square root of x squared minus 1. I don't know if it's working or not. Okay, I mean, we work together. If it doesn't work, then we spend more time figuring it out. So I don't want you to have too much pressure that you have to follow my way. Because showing equation is very flexible. So I mean, if this doesn't work, we switch to the other one. Okay, and when I'm doing this, I mean, I'm giving a lecture to you right now. It doesn't mean that you just go ahead and listen when I watch a video and listen what I say. You take a piece of paper and you work on a problem with me. Okay, don't just sit over there and look at what I'm writing. No, take a piece of paper, try to do it yourself. Okay, so if I let t equal to x plus square root of x squared minus 1, and because there's a conjugate of each other, they are conjugate of each other. So look at that. Look at this. Yeah, I think we can use different of square too. If I multiply both sides by If I multiply both sides by x minus x squared minus 1, because they go together with each other, then they are different of square part. Okay, so if I multiply both sides of this, then the left hand side become, just keep it there, but the right hand side is the difference of square. A plus b times a minus b, which is a square minus b square. Right, a square minus b square, right? So become a square minus b square. And square root of something square itself, so become x squared minus x squared minus 1. Distribute the minuses, so become x squared minus x squared plus 1. Cancel them. So you can have t x minus square root of x squared minus 1 equal 1. It means what? It means x minus square root of x squared minus 1 equal 1 over t. Right? Then what it become? What it become? So it become my equation, my original equation become, then my original equation become log base 2 of 1 over t. Right? Plus log base 3 of t equal log base 6 of t. Look at that. I simplify a very complicated equation to become a very simple one. Following me. Now, what I have here, log of the quotient will become difference of log. Right? Become difference of log. And log of 1 is what? Log base 2 of 1 is 0. So they become what? It become log base 6 of t plus log base 2 of t minus log base 3 of t equals 0. Okay, because this is cancel out. This is 0. Okay. Well, I mean, I can reorder like this if you want to. So I become log base. Let me rewrite log base 2 of 2. After you cancel log base 2 of 1 equals 0, and what you have is this. Okay, then I reorder them to give you that. Okay. So right now my equation is simpler. The problem is it doesn't have the same base. We have base 6, base 2, and base 3. What we gonna do? What we gonna do? Okay. How we gonna solve? How we gonna solve the thing that doesn't have the same base? You have to use a formula. It's called chain space formula. I believe in the lecture, the previous lecture, I already mentioned that. In the previous lecture, I already mentioned it. We need to do the chain space formula. Okay. And over here is base 2. I think I'm going to change everything to base 2 because we can see something similar with base 2 because base 2 is the smallest base. So I think I'm going to change base to base 2. But what is the chain space formula? Hopefully everybody remember. If we have log base b of x, then this become log base a of x over log base a of b, right? So it means what? It means if you have log base a of b times log base b of x, you see, if it's the same, then you have log base a of x. So it mean I can insert a number between log. Okay, I can insert a number between the log. So if I insert a b, you see that if I insert a b over here, log base a of b times log base b of x. Okay, then it works, right? So just think about it. If I insert number 2 over here, then it becomes log base 6 of 2 times log base 2 of t, right? Now this is, I keep it. Same thing away, I insert number 2 over there, so log base 3 of 2 times log base 2 of t equals 0. So all 3 terms over here, they have log base 2 of t. So I take them out. So what you have left is log base 6 of 2 plus 1 minus log base 3 of 2 equals 0. Right? No way that this one equals to 0, because this is number. Log base 6 of 2 is a number, plus 1 is a number, minus is this a number? Okay, so it means whether you divide both sides by this. So what you have left is log base 2 of t equals 0. You divide both sides by the whole thing inside parentheses. It cancel out, right? There you have t equal 2 to the 0 mean 1. So you got t equal 1. But we need to solve for x. So if t equal 1, you plug into the original one. So if t equal to 1, my equation will become x plus square root of x squared minus 1 equal 1. Right? And it become square root of x squared minus 1 equal to 1 minus x. Everybody know how to solve radical equation. You square both sides, so it'll give you x squared minus 1 equal to 1 minus x squared, which is 1 minus 2x plus x squared. I expand them out. So I'll give you x squared cancel out. So you're going to have 2x equal 2. Right? There you have x equal 1. And that is the only solution for this problem. Okay. In this problem, the naming variable process is more complicated. But you see that no matter what, how complicated a reasonable question is, if you use naming variable concept method, then you can solve any equation. I mean, I'm going to say like 95% of the question. Okay, so let me remember over here. So I'm going to use a change base formula. So I already mentioned it in the text. You can look it up in the text, or you can it's in the video. Okay, in the video. And this is the formula. I just said. This is change base formula. Okay, some textbook they use this form. So there's 2 forms. Okay, I just memorize one of the form that I can derive another form. This is the same thing. Okay, I think this form is better, but sometimes this form is good too. So for any log, you can insert a number in between the base and the argument. You know, and it's work. Okay, right. So I think that's all for the lecture today. We learned 3 methods: log principle, equivalence property, naming variable. Again, you have to do a lot of problems to get used to it. To master solving equation, that's the take required time. But I trust you guys. I believe in your ability. You're in this level already, so it's nothing hard, nothing that you cannot do. Okay, so be patient, keep working on the homework. Let me know if you don't get any step in the example. Send me a text message, send me a Canvas message that I'll try to respond to you as soon as I can. All right, and I'll see you next time. Bye bye.